We're going to be looking at segments and rays. We've already looked at lines last week, and now we're looking at parts of lines. So a line segment is all the points between A and B and including points A and B. You can call the line segment BA or AB, and it has to have a segment above it with no points on, no arrows on either side. That's what this little cloud says if it's hard to read. If you're drawing a ray, you'll have to have one arrow because a ray starts at the initial point and goes toward the point denoted by the second letter. So on line L, and with points AB, the ray AB starts at A, always at the first letter, and goes toward B and beyond B and on forever through B. So of course the ray BA would be different. It starts at B and goes toward A and on forever, and these two happen to be called opposite rays. Now I've given you just a little space to draw points J, K, and L. So I'm going to draw J, K, and L. I'm probably going to write over them when I start drawing my lines. This says to draw ray JK. So the initial point is J, and it goes through K. So initial point J, it goes through K and keeps going. Now we want to draw a segment KL. So it has endpoints K and L and stops. Ray LJ has an initial point L and goes through J and then continues. Make sure you put an arrow. Okay, segment postulates. A postulate is a rule that's accepted without proof. The ruler postulate says that you can place a ruler next to your line and line it up with the points. In this case, I'm lining it up according to the example down here, so that 0, look at my beat up old ruler, so that 0 lines up with A. So in this case, the coordinate is going to be x equals x1 equals 0. The coordinate of B, well, what is that? That's about 1.5 inches. That's what I tried to make it anyway. 1.5. Or you could say 3/2, that would be fine. So the real number that corresponds to a point is the coordinate of that point. So in this case, I've lined it up with A up with 0 and B up with 1.5. The distance between the 2 points is the absolute value of the difference between the coordinates. So in this case, that would be the absolute value of 1.5, that's x2, minus 0, which is x1, and that's 1.5. Now notice, if I started with x1 and said the absolute value of 0 minus 1.5, it's the absolute value is still a positive 1.5. So it doesn't matter which one is first. Now, so we've done example 1 now, but now we want to move the ruler so a different point lines up against A. So let's make 2 line up against A. Now we want to know what B should be. So if x1 equals 2, then x2, the coordinate of B, will have to be 3.5. Well, the absolute value of the difference of these two numbers is still 1.5, and that's the point. It doesn't matter where you put the ruler. The distance formula still works. And okay. So now we're going to look, and as I said, that's just basically common sense. I think you guys could have come up with the ruler postulate on your own. Segment addition postulate is also, I think it's common sense. If B is between A and C on a line, okay, then the length AB, which we write just AB with no line over it, plus the length of BC equals the length of AC. Now the converse is true too. If AB plus BC equals AC, then B is between A and C. So here is where as promised, a little algebra comes in to your geometry class. If AB is 2x and BC is x plus 7 and AC, well, what's x? Well, we know that 2x plus x plus 7 has to equal 28. So 2x plus x plus 7 equals 28. So 3x plus 7 equals 28 because we're combining like terms. So 3x equals 21 because I want to get the x. I want to isolate this term, get this term all by itself, so I subtract 7. Then I want just one x, so I have to divide by 3, both sides, x equals 7. Alright, now here we're going to look at segment bisectors. Segments that have equal lengths are congruent. Now a segment is a concept, okay? It's a thing. So it can't be equal to another segment. Instead, if its length is equal to the length of another segment, then those segments are said to be congruent. So you can say that in this case, the length AM, which is this, equals the length MB. And these little marks indicate that the segments are congruent. But what you would say in this point is that the segment AM is congruent to the segment MB. So the segments are things, they can't be equal, they're congruent. The lengths are numbers, they can be equal. So, but what we're getting at here is that M is the midpoint and it bisects the segment into two equal pieces such that this is true. If M lies on a line or a segment that intersects AB, then the line or the ray is called a segment bisector. We're going to find some similar rules with angles. An angle is represented by two rays with the same initial point. So here's the initial point, and then look, we have ray AB and ray AC. The rays are the sides of your angle. The initial point is called the vertex. So in this case, we have an angle with a vertex A and sides AB, remember to put your little arrow above it, and ray AC. Now the name of the angle, we've got several things we can do. We can call it angle A, or we can call it angle BAC. The vertex has to go in the middle. I forgot my little angle sign. So angle BAC, or we could call it angle CAB. But again, that A, the vertex, has to go in the middle. Now, sometimes you'll see on your tests or in your book, sometimes there's a number there. Let me make it better. That looks just like a line. See, number 3. Okay. And this can refer to the angle too, so this could be angle 3. Sometimes you'll see that. Okay, so the measures of angles are expressed in degrees. You've seen this when you've used protractors. I think most of you have used protractors. Angles with the same measure are called congruent. Again, angles are things or concepts. They can't be equal. They have to be congruent if their degrees are equal. So the measure of angle CAB and the measure of angle DEF can be equal because those are numbers. The actual angles have to be congruent. So if you have BAC or CAB, okay, and let's say that's 50 degrees. Put my little arrows, and you have DEF. And it's 50 degrees, okay? Then those are congruent angles. They have the same measure. Oh, they wanted 60 degrees. That was our example. Okay, 60 degrees. They have the same measure, so they're congruent. Their measures are equal. Okay. Adjacent angles are just angles that lie next to each other, but let's get some vocabulary out of the way. The interior of an angle is all the points that lie between the sides of an angle. So everything here is the interior of angle PSQ. The exterior would be everything out here, okay, for angle PSQ. All the points outside of the angle. Two angles are adjacent angles if they share a common side and a common vertex, but no interior points. So you can see they're neighbors. They're next to each other, but they don't share any points other than that common side. So we need that definition to understand the angle addition postulate. It's much like the segment addition postulate in that I think it's common sense, as most postulates are. Basically, two adjacent angles the measures of two adjacent angles add to the larger angle. So the angle addition postulate, in more technical terms, says that if Q is in the interior of angle PSR, then the measure of angle PSQ and angle QSR, those measures add to the measure of angle PSR. Basically, the neighbors add to make the combination. Okay? So, note, they're called adjacent angles, and yes, here's basically what I said. The angle addition postulate applies to the measure of all adjacent angles. So use the angle addition postulate to find the measure of the unknown angle. Now sometimes you're going to get algebra, just like we did with the segments. Sometimes you'll have maybe x and 3x here, and you have to, and then you know the measure of the full angle, and you have to make an equation and solve for x. But in this case, we're just adding them up to get the measure of DEG. So 28 plus 43 is 71 degrees. Okay. Now we're on a theme here. Now we're back to bisecting, and this time we're bisecting an angle. And we know that bisecting means dividing into two equal parts. So an angle bisector is a ray that divides an angle into two adjacent angles that are congruent. Okay? See how when you learn some vocabulary, it helps with your descriptions. So ray CD bisects angle ACB because it divides the angle into two congruent adjacent angles, ACD and BCD. See these little marks on the angle sign? Those mean that those angles are congruent. Those little tick marks, just like with the segment. When we had a segment, and we had the segment bisector, the tick marks meant that it was dividing it into equal parts. Okay. These are my endpoints of my segment. Okay. Here's our example. The ray FH bisects angle EFG. Given that, and I had started to draw it, but I drew it wrong. Given that the measure of angle EFG is 120 degrees, so that's probably about like so. What are the measures? So if here's EFG, what are the measures of each of the smaller angles? We know they have to be congruent. The angles are congruent. So what does that mean about their measures? It means their measures are equal. And so 2 times x equals 120 because the total is 120, so x equals 60. So